Greetings from Department of ECE, SJBIT. I am Anita talking about Module 3, which is ARM Embedded Systems. ARM Embedded Systems. Under that, in the previous session, which we have discussed about risk design philosophy and ARM design philosophy. Next, we will be looking into embedded system hardware. So, in embedded system hardware, it majorly concentrates about the hardware components. So as we know that embedded systems can control many different devices, starting from sensors to the real-time control systems. All these devices which will make use both the hardware and software components. So if you look into the diagram, you have a ARM processor as a core, and you will have a controllers, peripheral units, and you will have a buses. So the dark one which indicating a processor, next one lighter one which indicates about the controllers, like it could be a interrupt controller or memory controller, or it could be a bridge network between the AHB and APB bus architecture, or it could be a AHB arbiter. All these will come under the controllers. Memory controller, which will control the memory which is connected to the processor. Similarly, along with that, you will have a different peripherals. So peripherals, like it could be a UART or a real-time clock, or it could be a Ethernet or counters, timers, anything of it could be. All these has to be communicated through electrical signals, so that will be passed through a bus. So you will have in hardware components majorly, you have a core and you have a controller, or you have a peripherals which are connected to, and all these will to communicate you have a bus. So the four major components in any ARM hardware system, if you observe, you will have a processor, you have a controller, peripherals, and the bus. The ARM processor, which indicates about a core execution engine that majorly processes the instructions and manipulates the data, and which is surrounded by majorly memory unit. Two components majorly, which is nothing but a memory, primary and cache memory. The processor which will also controls the embedded device. So there are different versions of ARM processors which are available. The one which it suits for the desired application has to be chosen. Then coming to the controller, the purpose of controller is to coordinate the important functional blocks of the system. Majorly found controllers are interrupt controller and memory controllers. So along with that, you have a peripherals. So all the peripherals, they provide all the input output capability external to the chip connection, which is external to the chip, and it is more responsible for uniqueness of the embedded device. Means how many peripherals that you can connect, depending upon that your embedded system will have a major applications. Then you will have a bus which is used to communicate between the different parts of the device. So coming to one by one, coming to the bus technology. So all the embedded devices, they use on-chip bus, so that is internal to the chip, and it allows the different peripheral devices to be interconnected with the ARM core. So here in the diagram you can observe you have three different buses: AMBA AHP, AMBA ASB, and AMBA APB. Soon we will look into what are these AMBA versions. So AMBA indicating it is advanced microcontroller bus architecture. Under that advanced microcontroller bus architecture, you have three variants: AHB, ASB, and APB. So APB, the name itself indicates advanced ARM high performance AHB indicating a high performance bus, AHB, APB indicating a peripheral bus. If I want to connect the peripherals to the ARM core, which is through APB, AHB, which is to connect a high performance ARM high performance bus. Next you have ASB, which is indicating ARM system bus. So within the processor you will have either AHB or ASB. So it could be high performance bus or system bus. Major difference you can observe between these two is you have a in high performance bus you have a burst transfer of data. Remaining things were same. Coming to peripheral bus, it operates at a low power, and you have a latched address and control bus and simple, which is a simple interface suitable for many peripherals. To bridge the AHB and ASB with APB, you have a bridge network. You can observe this. Sorry. Hayo Rama.